equation of continuity. What is equation of continuity? So the principle states that for a steady state flow, the mass flow into the volume must be equal to the mass flow rate out. What does it mean? It means that if you consider this pipe, so this pipe has a non-uniform cross-sectional area. If you see here, so this pipe, it has a cross-sectional area A1, and here it has a cross-sectional area A2. Okay. The fluid at area A1 passes with a speed V1, and the fluid here at area A2 passes with a speed V2. Understand? Now, what is equation of continuity basically? Basically, equation of continuity, it is based on law of conservation of mass. It is based on law of conservation of mass. It means that equation of continuity is a mathematical expression which deals to define the conservation of mass in a fluid dynamics. Whenever a fluid is flow into the pipe, so the same fluid which is going into the pipe, it will become equal to the fluid which is going out from the pipe. It means that equation of continuity is basically based on the conservation of mass. Okay. And first of all, if you see here, so here we have this area A1 where the fluid which covers the distance at area A1, that is equal to S1, and that S1 is equal to V1 delta T. We have a famous equation, that is S is equal to what? Vt. And according to this equation, S1 is the distance which is covered by the fluid when it passes through this area A1 in a delta T time, having the fluid speed V1. Okay. Similarly, let's say this is equation number 1. Similarly, the fluid which passes through this area A2, it with a speed V2, it covers distance delta, that it covers distance S2, and that S2 is equal to V2 delta T. Understand? So now if you see here, so we have these two equations. S1 represent the distance of the fluid which it covered when the fluid is passes through area A1, and the distance of the fluid which when it passes through area A2 is S2. Now the volume of the fluid, which passes through A1 is, so as you know that if delta V1 is the volume of the fluid which passes through this area A1 is equal to S1 multiplied by A1. And as you know that volume is equal to length zarbi width zarbi height. Okay. So area is length multiplied by width, and S1 is the distance. So if you multiply distance with volume, it will give you, if you multiply distance with area, it will give you volume. Okay. Similarly, the volume of the fluid which passes through this area A2, that is equal to delta V2, and again that is equal to S2 multiplied by A2. Okay. Now if you see here, so delta V1, it will become, what is S1? S1 is V1 delta T A1. What is S2? That is delta V2 V2 delta T into A2. Let rho is the density of the fluid which passes through this area A1 and similarly area A2. So what is density? Density is actually mass per unit volume. Understand? So what will be the density of the fluid which passes through this area A1? What will be its density? Its density will be rho delta M1 divided by delta V1. Clear? And what will be the density which passes through this area A2? That is equal to rho delta M2 divided by delta V2. Okay? Let delta M1, it is the mass of the fluid which passes through this area A1. So it will becomes equal to rho delta V. Let's say this is equation number 3, and similarly delta M2, it will becomes equal to rho delta V2. Let's say this is equation number 4. Now you should remember that for a steady state flow, okay, what? For steady state flow, delta M1 will become equal to delta M2. Understand? When there is a continuous flow in a pipe, so delta M1, the mass fluid through this area A1, will be equal to the mass flowing through this area A2. Okay? So what will be the value if I put here? What is delta M1? Delta M1 is equal to rho delta V1. What is delta M2? That is equal to rho delta V2. So what is the value of delta V1? Put the value of delta V1. What is that? Rho delta V1 is equal to V1 delta T A1 is equal to V2 rho V2 delta T into A2. So I put the values of delta V1 and delta V2. Okay. So rho will cancel with rho. Delta T will cancel with the delta T. So V1 A1 is equal to V2 A2. This is called equation of continuity. This is called what? Equation of continuity. It means that the product of the fluid speed multiplied by area of cross section, it will be equal to the fluid which passes through area A2 multiplied by the speed of the fluid at area A2. Both will be the same. This equation is called equation of continuity, and continuity equation, it means that here is some VA is equal to some constant. So what is this constant equal to? So you should remember that this constant is basically the time rate of flow of volume of liquid multiplied by time divided by time is equal to VA. So here from this equation we can conclude that V is inversely proportional to the area of cross section. Whenever you will increase the cross sectional area of a pipe, the speed of the fluid will be decreases. Understand? And if you decrease the area of cross section of pipe, the fluid speed will increase. So we have so many examples in our everyday life. If you take the example of deep water and as well as the water, the place, if you take the example of river, okay, river. So in river, when we take the example of deep water, okay. So in deep water, the speed of water is very, very less. The water is flowing at a very low speed as compared to if you take the example of shallow water, okay, shallow water. So shallow water, where the water moves with a very high speed. So why? In deep water, the area of cross section is very high. So that's why water moves with a very less speed. And in shallow water, the area of cross section is less. So that's why water moves with a high speed. Understand? So another example, if you take the example of this pipe, okay? So in this pipe, we have two cross-sectional areas. Here, water will move with a very low speed because area of cross-section is high. But here, water will move with a very fast speed because area of cross-section is what? More. So this is called equation of continuity, and which is based on what? Law of conservation of mass.